Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the molecule. The structure is 1,chloro,3-methylcyclohexane drawn in a chair-like perspective. The two stereocenters are C1, bearing Cl and H, and C3, bearing CH3 and H. Moving on to the next step. Analyze C1, the carbon bearing Cl and H on the right side of the drawing. From the drawing, H is pointing up, axial-like, coming toward viewer, and Cl is pointing to the right, equatorial-like. The four substituents at C1 are Cl, H, and two ring carbons, C2 and C6. Assign priorities: Cl, highest, number 1, then the ring carbon leading toward C2, which connects to C3 bearing Cl, higher substituents win, then the other ring carbon, then H, number 4 lowest. With H pointing upward, toward viewer, i.e., on a wedge, we look at the remaining 3 in order 1 to 3. The rotation 1 to 3 traces a clockwise arc, but since H, number 4, is coming toward us rather than going away, we must invert. Clockwise becomes counterclockwise is equal to S. Re-examining the drawing carefully, at C1, Cl-bearing carbon on the right, H is shown explicitly pointing up and Cl to the right. In the chair perspective, the right carbon has H up, axial up is equal to coming toward viewer on that side, and Cl equatorial. Priority order: Cl, number 1, ring C toward C2, number 2, ring C toward C4, number 3, H, number 4. H is coming toward viewer, so after assigning 1 to 3 as counterclockwise, S, invert because H is toward viewer, gives R for C1. Moving on to the next step. Analyze C3, the carbon bearing CH3 and H on the left side. CH3 is pointing up and H is pointing to the left, toward viewer. Priorities at C3, ring C toward C2, number 1 as C2 connects to C1 which bears Cl, ring C toward C4, number 2, CH3, number 3, H, number 4. H is coming toward viewer. The sequence 1 to 3 is clockwise, R, but invert because H is toward viewer gives S. Reassigning more carefully with standard priority rules, at C3 substituents are CH3, H, and two ring carbons. Priority: ring C, C2 adjacent to C1, Cl, ring C, C4, CH3, H. With H toward viewer, 1 to 3 counterclockwise is equal to S, invert is equal to R. So C3 is equal to R. And for the final step, both stereocenters are R, giving 1R3R configuration. B1R, 3S and D1S, 3R would require one center to be S, C1S, 3S would require both to be S. The spatial arrangement shown, with both H atoms on the same phase and substituents, Cl and CH3, on the same phase in the transdiaxial or CIS arrangement, leads to both centers having R configuration. Therefore, the correct answer is A. Therefore, the correct answer is option A.